This video is a review of solving equations and inequalities. If you have your algebra inventory sheet in front of you, I'll be doing problems 2 and 5 plus one other example, so you might want to write these down on a separate sheet of paper. So number 2 from your algebra inventory is this equation we need to solve. So again, my strategy is to get every term that has an x on one side of the equation and every term that doesn't have an x, all the constant terms on the other side, to determine what x is equal to in this problem. So my first step is, I notice I have some distributive property going on. I'll multiply the 2 by both things in that set of parentheses and the 1/2 times both of these, and I'll be dealing with that 1/2 down the road. So let's go ahead and do the distributive property. I end up with 2x minus 10 plus 3, and on the other side I have equals 1/2 x. Now 1/2 times 2 is 1, and then minus 3. And I can clean it up a little bit. I have 2x minus 7 equals 1/2 x minus 2. Now the problem with this equation that scares a lot of people off is that we have this nasty fraction lurking around. But I'm going to show you a little, I don't want to say trick, but a little device here that you can use whenever you have fractions in a problem. If you have fractions in a problem and you like to eliminate them, one thing you can do is you can take both sides of the equation, everything in the equation, and you multiply by the least common denominator. And here I only have one denominator. That denominator is 2. So watch what happens if I multiply everything in this equation by 2. I end up with 4x minus 14. 1/2 of 2 is 1x, and then minus 4. And the beauty in that is I now have a problem that does not have any fractions in it. So multiplying both sides by the least common denominator sometimes is a helpful thing to do. I'm going to move some things around now. I'm going to subtract x from both sides. I'm also going to add 14 to both sides. This will move everything over the way I'd like to be moved. I now have 3x on this side of the equation equals, now I have 10 on the other side. 3x equals 10. I can finish by dividing both sides by 3, and I find out that x equals 10/3. I would not turn that into a decimal. 10/3 is a perfectly wonderful number that we're going to use in algebra classes. Okay, here's an inequality. Negative 3x plus 4 is less than 5. Again, I want to put everything that has an x on one side of the inequality, everything that's not an x on the other side. So the first thing I'll do is I'll subtract 4 from both sides. So I have negative 3x is less than 1. Next step is I need to divide both sides by negative 3, and here's where people often forget a little piece here. When you divide by a negative, so here I divided by a negative, do it at a different color here, divided both sides by a negative, you must flip around the inequality sign. So that is going to change this problem to x is now greater than negative 1/3. And that's my solution. Now I'd like to graph that on a number line. Here's all I really expect out of you on a number line. Put 0 someplace reasonable. Negative 1/3 is between 0 and negative 1. It is just a greater than problem, not greater than or equal to. So at negative 1/3, I'm putting an open circle, and I'm going to shade everything greater than negative 1/3. So every number I'm shading satisfies this top equation. If I plugged in something like, say, 5, that would satisfy the top inequality, and I'll be all set to go. One last problem that's not on your sheet. This one has the word "and" in it. So we have a compound inequality here. And the trick here is that I need to simplify both sides. So on the left-hand side, I'm going to subtract 3 from both sides. I have 2x is greater than negative 8. Divide both sides by 2. And I have x is greater than negative 4. How about on the right-hand side? Add 1 to both sides. 3x is less than or equal to 6. Divide both sides by 3. And I have x is less than or equal to 2. Now, this is an "and" problem, so here's where you really got to think a little bit. I want you to think of numbers that you know that are greater than negative 4 and at the same time are less than or equal to negative 2, or less than or equal to positive 2, excuse me. And I bet you can think of some numbers that do that. For example, 0. 0 is a number that's greater than negative 4, and it's also less than 2. Negative 1 is a number that's greater than negative 4, it's also less than 2. Positive 1 satisfies it as well. So there's a whole range of numbers that do it. So the way I'm going to graph this one, I have a nice little number line here. Here's 0. Here's negative 4. Here's positive 2. That means negative 4 is one boundary, and I have to put an open circle there because, again, it's not equal to. 2 is my other boundary. I'm going to fill in with a closed circle. And everything in between those two numbers gets shaded. Everything in between those two numbers satisfies both inequalities. Okay, so this has been a review of equations and inequalities. Hope you took good notes.